So as we talk about this morning, I want you to start to think about a future that has those vehicles, has them available to everybody. And then as we go through, you'll begin to see why the Air District is so interested in these electric vehicles. So who is the Bay Area Air Quality Management District? We were established in 1955. We have a jurisdiction of 9 counties here in the Bay Area. That's 5,340 square miles and a population of 7 million people. So all we have to do with those folks is have them agree that they want to protect our health, improve air quality, and protect global climate, and that's our mission. Pretty easy, right? So why would an air district be interested in something like electric vehicles and electric vehicle charging infrastructure? You have to consider that in the Bay Area, passenger vehicles and trucks account for 25% of the air pollution. That's 25% of the toxic soot that you breathe, and they're a major cause of ozone. And ozone really impacts you when you've got asthma and those health bronchial related issues. It's okay, we can do without it. These folks have the power. I know, I can feel it. So, on top of that, they're also responsible for about 28% of your greenhouse gas emissions. Primarily, that is that black carbon. Black carbon has the, while it does have a cooling property in clouds, its major things that it does is it really forces those temperatures up in the short term worldwide. So for us, electric vehicle technology is a promising solution for us to meet our health goals and for us also to reduce those greenhouse gas emissions. Why is that important? In 1955 in the Bay Area, we had approximately 3 million people living here. And those people had 1.7 million cars. And they traveled 35 million vehicle miles on a daily basis. In the year 2006, we have over 7 million people living here. They have 5.3 million cars. And those cars travel 170 million vehicle miles daily. For each one of those miles, there's an equivalent amount of air pollution that's emitted from those vehicles that impacts your health and impacts the health of our planet. As we think about electric vehicles, there's a whole plethora of different types of vehicles that we can imagine. One of the ones that's very popular in certain communities is neighborhood electric vehicle. They're almost like a golf cart. They're slow in terms of regular automotives. They go up to about 25 miles an hour. They're fully electric. Hybrid electric vehicles, everybody knows the Toyota Prius is probably the most ubiquitous type of electric vehicle that we have out there. And that vehicle works on a battery that's charged by the actual motion of the vehicle itself. Now, as we take that concept a little bit further, imagine if we had the ability to plug that battery in, and what that does is it extends the range of that Prius or the range of that Ford or Chevrolet Volt, or by actually allowing the driver to operate on the electric battery for longer distances. Currently there are a number of manufacturers bringing vehicles out onto the market that are fully electric. Those cars can be plugged into a wall and can give you up to 100 to 200 miles of vehicle range just on something that comes out of the wall, and there's no tailpipe. That means zero emissions. So as we look at those particular vehicles, we have got to figure out, well, how do we actually get the power into them? When you think about your own gasoline automotive vehicle, you know that there's a gas station on every corner. What about if you've got an electric vehicle, or if you've got something that needs to plug in? There are a couple of different types of charging. Level 1 charging is 120 volt. That means you take a plug out of your wall with an extension cord and you plug it into the back of your car. That's level 1 charging. Level 2 charging is where you would take a plug out of your dryer plug. You run it through a transformer and then you plug that into the back of your vehicle. That is the main standard that will be used for these new vehicles. And unlike when these vehicles were released in the late 1990s, there's been universal agreement that there is now a set standard and a set type of plug. So anybody who has one of these vehicles will be able to go to anywhere there's a level 2 charger and know that they can plug that vehicle in. Okay? DC fast charging. DC fast charging is the closest thing that we have to a gas station in terms of electric vehicles. It basically takes what comes off the power lines and plugs it directly into the battery of a vehicle. It's quick charging. It's not as quick as gasoline refueling, but it gives options to folks who don't live in residential homes where they can install either the level 1 or level 2 charging. And then there's a third concept, which is battery switch. That's where you bring your vehicle in, and in less than a minute, electronically, a robot comes up, takes the depleted battery out of the bottom of your vehicle, unplugs it, and replaces it with a fresh battery, and that is the closest thing to a gas station that you will see. These are currently running in Tokyo, and we are currently funding one with our partners MTC in San Francisco that will be online by the year 2012. So, and I'm really glad that we got this up, because I'll be able to show you where all of this stuff is going in. So, in terms of potential barriers to electric vehicle adoption, in my future, everybody drives these cars, but in order to get people to actually take that step, there's a number of things that we have to consider. There's an incremental cost associated with the vehicles and charging infrastructure. That's because of the cost of the batteries. And that cost of batteries is going down because of the investment of the federal government in massive battery manufacturing throughout the nation. But currently, the cost of an electric vehicle over the cost of a regular vehicle, there's quite a high increment there, maybe up to $10,000 or $15,000. The second thing is, nobody obviously wants to get stranded with an electric vehicle. Folks are anxious about range, and it's that part of the equation that the Air District's programs are really designed to start addressing, and we'll talk about that a little bit more in the presentation. And then the last portion of it is okay, suppose I want to have an electric vehicle, suppose I want to buy one. How do I go about getting a permit for this? If I walk down to my local building department and say, yeah, I'm going to put a fully electric vehicle or DC fast charger in my house, have you got a problem with that? Is an electrical engineer or planner going to look at you and go, well, that would be very nice, but it's going to take us 6 months to figure out what exactly you're doing in your home. Those are some of the challenges and some of the issues that we have to deal with. So how are we going about dealing with that? Recognizing those issues, the Air District has been working for a number of years now to actually provide a network of public chargers that are those level 2 chargers that will plug into all of these newly manufactured vehicles. You can see here that there's a ring that we're ever so slowly providing a ring of chargers around the bay here. As we look at it, we expect most people to charge in their homes, but if you don't charge in your homes, what we want to have out there for you is an available network where you can use your smartphone or you can use your internet connection to find out where there's a charger that's publicly available to you nearby. On top of the public chargers, we're going to announce on Tuesday of next week an additional 2,750 chargers that we're providing for people in their homes. We're doing that primarily because we want to learn a little bit more about the vehicles themselves, learn a little bit more about the charging patterns, and with that information we'll be able to figure out what we need in terms of deploying the infrastructure for these folks and making electric vehicles accessible to everybody. I talked about the battery switch station. That one is going to go in downtown San Francisco. That battery switch station is going to be accompanied by 3 others that will form a network that travels from San Francisco all the way down to San Jose. And you'll be able to switch your battery out from your vehicle at any point along those areas. And also we're going to deploy 36 fast chargers. Those 36 fast chargers are going to be located along our Bay Area highways and travel corridors. So what that does is that really addresses the range anxiety portion of that last slide I showed you. It gives people the confidence that there's a network out there, at least in the Bay Area, that will support them and allow them to use these electric vehicles. For every electric vehicle mile that's traveled, that means less air pollution that we have to breathe. less consequences in terms of global warming, and less consequences in terms of importation of foreign oil and the expenditure of that fossil fuel. So the last portion of it there kind of totals up what we've been doing. There's a lot of other people who are active in this area. There's a lot of this work going on here, and there's a lot of companies here in the Bay Area. Tesla Motors are about to open a factory in Fremont where they will be producing electric vehicles, 2 different types of electric vehicles. They're going to produce electric drivetrains for the Toyota company, for fully electric RAV4s, and they're going to produce their own electric sedans. We have 2 other companies who are out there under grants from the federal government who are putting in more of these public chargers. That's Clipper Creek and Coulomb, both of whom are located, Coulomb are located in Palo Alto. That battery switch station is being put in by a company called Better Place, who are located again in Palo Alto. So as you consider these electric vehicles, you're considering local businesses, you're considering a change really in the way that we live our lives, and a change in how we'll be able to do our automotive transportation. And then the last thing that I really want you to consider is that in this future, the power that we're using, because these resources really are going to be designed to plug in at night. We're going to be using clean, renewable power that comes from our wind turbines, that comes from our hydroelectric, that at night time none of us are using. What that means is that plants, such as the ones that provide us power here in California, will be able to run more efficiently. Whether that translates in savings to us, I don't know, but in theory, that should mean cheaper electricity for everybody. So I'll leave you with that, and I'll be ready to answer any questions. Thank you for your time.
We're going to take a few minutes for questions. What is the potential for retrofitting current cars to be plug-in electric capable?
There are a number of different, well obviously it depends on the initial vehicle, but there are retrofit kits out there that can make everything from Ford F-150s to the current sets of Priuses available with battery, plug-in battery packs. The question is, as you consider those, they are quite expensive. They can range from $10,000 up to $40,000. So one of the things that you have to consider is, do you want to go with something that's available in retrofit, or do you want to buy something that comes from the manufacturer? Now all of this is warranted. And where it becomes important is, it depends on how much you use that vehicle. A $40,000 investment for a construction truck that's used every day, day in, day out, and can amount to a massive fuel saving. So it all depends. They are available, they're out there, but it really becomes down to a business decision. What does that weigh up for you in terms of dollars and cents?
Thank you. Question about electric vehicles. Sustainability factor. Does it include battery disposal, cost of construction of the car, and cost of disposal at the end of its life?
Well, we're not much for disposal at the Air Quality Management District. Recycling. And one of the things that's very important with the electric vehicles is the recycling of the batteries. When you consider that for most electric vehicle uses, the manufacturer would say that once that battery reaches 80% of its cycle, or where it can only reach about 80% of the charge that's in that battery, they would like to swap it out and replace it with the new one. That battery has an immense amount of storage left in it. And one of the things that we see, and I think one of the things that the federal government sees going forward, is that battery could be used to store energy to be applied at peak moments when we have power spikes in our grids. It could be used to store the energy from wind that occurs at night. Wind blows mostly at night, and that's when our largest peaks are. It could be used to augment the power that we get from solar, the power that we get from hydro. So the actual recycling of the batteries is something that we're very excited about. And what was the rest of the question?
Well, battery disposal, cost of construction of the car, cost of disposal at the end of its life.
Yeah, in terms of the actual life cycle of the vehicle itself, those analyses have been done. In terms of the cost of running the vehicle, they're about a quarter of what it would take to run an equivalent gasoline vehicle because of lower maintenance costs. And then in terms of the actual wells to wheels, they still work out better in California, mind you, because of the amount of renewable energy that we have here in our portfolio. In other areas, it might not be. It may be at parity to say fossil fuel vehicles. But here in California, there is a benefit in terms of greenhouse gases and in terms of pollution of using those vehicles. If you imagine that in terms of controlling the emissions, it's a lot easier to control them from one. Most of the power plants that we have now, because of the new emissions controls, are actually emitting at levels where we have to use the instrumentation that we use to measure background air levels, versus where we put the same instrumentation on the back of your current car or whatever that you drove here, your current vehicle, that it would be probably ruined in 10 seconds. So there's a big difference between those two things.